All right, so this is due today, this and the other sheet. I'm actually going to do two separate videos. So this one will be less than 5 minutes than the next one. Um, so this one, I'm going to show you my screen here and go over this. The next worksheet, um, let's see, this one, I'm going to record myself using that piece of 2x4, 1x4. I forget what it is. It's not a 2x4. Anyways, so here we go. All right. What information on the graph indicates the system is initially at equilibrium? So the answer to number 26 is that the initial concentration of H2, NH3, and N2 are all constant. So equilibrium, if you remember when I first started talking about this, and I've said this many, many times, it isn't about anything to do with being equal. It's about being balanced and constant. So if you go to the top of the page here, you look, you have 1 mole of N2, 3 moles of H2, and 2 moles of NH3. So the best way to explain this is we have 1 mole here, we have 2 moles here, and we have 3 moles here. As long as those 3 moles of hydrogen, those 2 moles of ammonia, and 1 mole of nitrogen are constant, meaning not changing, that means every time one of these and 3 of these make one of these. So 1 mole of N2, 3 moles of H2, every time they combine and make 2 moles of NH3, the exact same time, 2 moles of NH3 are breaking apart, making 3 moles of H2 and 1 mole of N2. So again, up here, basically if you're going to the right at the same rate you're going to the left, and that's occurring at the exact same time and speed, you are maintaining equilibrium. And if that is the case, then the concentrations of these three will never ever change. Because every time, think of the rotating door in a hotel, right? One person walks out, one person walks in, one person walks out, one person walks in. It doesn't matter how many people are inside and outside, not the number. It's the fact that the amount of people inside and outside stays constant. And that's what equilibrium is all about. So because these concentrations are constant, that represents equilibrium. That is the answer to number 26. Now, in terms of Le Chatelier's principle, why final concentration of NH3 is greater than the initial concentration of NH3. So if you look at this, what happens is they start out at equilibrium. H2 is added to this reaction. That means H2 spikes. So as you add H2, it reacts with N2. So that's what happens here. So you add H2, so you dump a bunch in, it spikes, meaning you're increasing the concentration. As those H2 particles collide with the N2, they react. And when reacting particles react, they start to decrease in concentration. And as they react, what are they making? They make NH3 products. So as H2 and N2 react with each other, they use themselves up to make NH3, which is why the concentration at the end is higher than at the beginning, because it was created through the process of this reaction. So as H2 and N2 react, they collide effectively, they make product, which is NH3, which is why NH3 has a higher concentration. And that is the answer to 27. 28. I just answered that. I'll say it again. So basically, as soon as you add H2, it spikes. All right. So imagine you add gas to a car that's running. Okay. It doesn't happen this fast, but as soon as you add gas, it's going to start to react and burn and combust because the car is running. It would be a slower process, but that's the analogy popped in my head here. So as soon as you add, it's like, all right, you throw fire or throw more wood on fire, right? It'll start burning as soon as it touches that fire. So that's the same thing. As soon as you add more reactant, it starts reacting. So you add H2, it immediately starts colliding effectively with N2, therefore producing more ammonia. That's why it starts to decrease, because it starts reacting immediately, colliding with the N2 effectively. And that's, there you go, collision theory. So you would say as soon as the H2 particles are added, they start to effectively collide with N2, making more NH3, which is why it starts to decrease. All right, I'll stop this because that is it for this one.